the video solution of exam 12 prototype. Okay, let's go to the network directory. I open any directory. I type //ubz01fst. Since I'm not at university, I also add .unibz.it. Courses, exam collecting. Okay, there will be a long list of people. I search for myself and I copy all the stuff on my desktop. Since my desktop is rather a mess, I prefer to copy the stuff to a directory. Okay. I open this directory and I start working. The database is disksong.accdb. Since it's a new database, I will give you the database schema sometime before. Let's see, however. Okay. Create query 1, which asks for a year of production and shows the list of disk and song, only titles must be displayed, produced in that year. There's also a picture to help you for year 2008. So create, well, let's do it in query design. Year of production, it's in disk. Disk and songs, so also songs. Okay. So, title, year of production. Tell me a year. This must not be displayed, so let's test it. 2008. Okay, DJ kids, yes. Well, I don't care about the order of the fields, but just to have it identical to the picture. Okay. Save query 1. Close. Create query 2, which counts for each person how many songs has he authored as text writer. So create, I go to query design directly, person, authorship, type, text writer, person. This doesn't need to be displayed. No, wait. We have to click on totals because it's summary query, group by. Well, I have to count the songs. So you can either count this thing here, it will work, or you can, if you want to do it perfectly, song and count the song ID. Count, where's count? So, okay. Create form 1 to edit people and songs they perform with the instrument. Lock the form to avoid people's deletions and modification and to avoid songs insertions. So this saved as query 2. Close, create form wizard from what do we need here? People, so person, here it's person name and nationality, and performing, title, track, instrument, song, instrument, track is not required. Okay, next, yes, like this, next, form, the name should be form 1, leave performing subform as subform, finish, okay, I switch to design view. Now, property sheet, this is the property of the main form. I have to lock to avoid people's deletion and modification. So, allow deletion, no, allow edits, no, okay, close and save. Now I have to open the other one, this one, to avoid songs insertions, additions, no. Okay. No. I don't trust access, so I will recheck. Oops. Design view. Okay. Property sheet. Yes, it's okay. Okay, add a new field country to table person with mandatory list with drop-down menu built through another table called countries with inside values Italy, UK, Germany, US. Okay, so we have first to build a new table. I will go in design view, field name, country. Well, the field name will be also primary key. Where is primary key? Okay, done. If you want, you can build the country ID primary key and then, well, let's do it, but it's perfectly the same. So we have to remove this as primary key, put this as primary key. This will be auto number. Okay. Just to have it. Okay. Show text, that's okay. Save the new table, countries. Okay. Switch to design view. Country, Italy, UK, Germany, US. Close. I don't need to save when I put the data inside. Here I have countries table. Now I have to build a relation. So, well, I prefer to go to person, open it in design view. Okay, country. Not short, but lookup wizard. Get from another table. Table countries. I will display country. Okay. Okay. Enable data entry. Enable data integrity. Finish. Yes. Done. Okay, let's check it to be sure in the relationship wizard. Show all. Yes. Okay. Perfect. Create. Okay, let's go on. Create query tree, which displays the only person who is not an author. So create query design. Let's go in query design directly. Person, authorship. Okay. How to display the only person who is not an author? Well, who is an author? You just click here. You choose person name. If you want to get to know for which, okay, you just click here and you get the people who are authors. Who is not an author, you have to click here, change to number 2, which displays all the people regardless of what is here. So in this case, you will see authors and not authors. Okay. And how to get who is not an author? The people who are not an author are the people who have an ID empty on this table here. So can you see this Nicola Manzan? How to display only him is null. Up, done. So save query tree. Okay, we have now to import table houses into a new table houses. So let's close external data. It's a text file. Browse. I go to my desktop. Sam houses. Oops, I am exporting. Pay attention. No, 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 no. I want to import. So from here, text file. If you want, you can convert it to Excel and then import it, but honestly, it's much faster like this. Okay, fields are delimited or fixed wide. Well, delimited. Okay, the delimiter is a tab. Let's see, the date, there are not date in this, just take a look at it, only numbers. Okay, so we can go at the decimal symbol. It's not a comma, but it's the dot. Pay attention. Oops. tab, wonderful. It is an integer is enough. Indexed, yes, no duplicates. It will be a primary key. It is not a long integer, but it's a single. These two. Why don't I have the field names on the first line? Here, first row contain field names. Okay, finish. Let's see whether the import has been done correctly. Yes. Okay, we close. Okay, this one is finished. This is the net. Don't pay attention. This is the network directory and not the directory in which you're doing the exam. This is the exam directory. Okay, this song, in fact, it has been updated. Okay, turn the page and let's go to our exercise. We open R. I have here prepare our portable. We open sleep questionnaire. It's a questionnaire which you know very well, so I wouldn't give it to you some minutes before. Change working directory. Okay, let's from our console load workspace sleep questionnaire.rdata. Here you change. Okay, let's see whether it's the usual one. Yes, it's the usual one. Let's see. Analyze graphical use sample for marital status using colors blue, red, yellow, black. So what should we do here? Well, either the pie chart or the bar plot. I will do both just to show it to you. Well, you can either change the color palette or use col equal C blue, red, yellow, black. I change the color palette here. So we start with blue, red, yellow, black. Okay, change the color palette. Well, I will put a little note. Okay, for the professor, but I will give it for granted if you use the color palette. Meanwhile, I will open the Word file, which I will put all my stuff. Okay, graph, bar graph, Marital. Okay, let's see the graph. All gray because I'm not using the color palette, so I have to add here comma col equals C 1, 2, 3, 4. Okay, copy as bitmap. Op, done. Exercise is already done, but I will just do also the pie chart just to show it to you. This is one of the cases in which probably a pie chart is even better. Okay, obviously not with these colors. Where is the pie chart? Okay, pay attention here to the parentheses 1, 2, 3, 1, 2, 3. Okay, op, see 1, 2, 3, 4. Okay, copy as bitmap. Okay, save because you never know what happens during the exam. So exam.docs. Okay, let's go on. Convert variable sat sleep into an ordered factor. So how do you do it? Well, I do it manually. Sleep questionnaire dollar sat sleep equal ordered. Oop. sleep questionnaire. $sleep. This is the straightforward way. Okay. That's it. I just submit this one. Yes, you can see it has levels and the levels are in order. So it's now an ordered factor. Okay. We code variables trouble sleep, trouble stay, wake night into factors with 3 levels. Okay. Hey, I will also write here in the okay. Sat sleep now is ordered. And just to make the professor happy, I will also write its levels. Okay. We code variables health rate, fit rate, weight rate into factors with 3 levels, low from 1 to 3, medium from 4 to 6, and high from 7 to 10. So let's do it. Data, record variables, reset. So health rate, weight rate, and fit rate. Where is fit rate? Okay. I will add a prefix since I'm doing a massive record. Recorded. Okay, each new variable a factor. 1 to 3 equal low. 4 to 6 equal medium. 7 to 10 equal high. Okay. Let's see. Just to have an information that I did it. Please don't put too much information showing me that you're doing copy and paste. Okay, recorded weight rate. Okay, yes, this is enough. As factor is superfluous. Okay, this way we have an idea of what we have done. Let's take a look at it because you never know. So health rate here is 10, fit rate 7, weight rate 5. Health rate high, high, medium. Okay, perfect. Okay, and let's go on. Analyze graphically and numerically variable weight. So let's start with graphically. Weight is a scale variable, so we have box plot. Okay, let's copy this horrible box plot. Oh, let's do also the histogram, even though it's not required. You just do one of the two. Well, it's good choice of intervals. Okay. By the way, let's save the script because you never know as exam.r the output because you never know as exam.txt and also the workspace. Let's leave the original name sleepquestionnaire.rdata. Yes. Okay. Also numerically, so statistics, summaries, numerical summaries for variable weight. Let's see, mean, standard deviation, interquartile, yes. Okay. So let's copy and paste here. Okay. Let's use the standard fixed font, which is Miriam fixed. Okay, save. Test whether the average weight of the population can be 70, paying special attention to prerequisites. So, I'm testing the average, so there is only one test which I can do. It's a single sample t-test. Okay. Wait. mood 0 is not 0, but it's 70. Okay. Click. Okay, the mean of the sample is 73. P-value 0.0000. So let's copy and paste here. So we are doing students one sample t-test. This is the result of the t-test. H0 was average on the population for weight is 70. H0 rejected. Average is for sure, with such a small p-value, I can say for sure, not 70. Okay. Save. I delete all the irrelevant information, paying special attention, however, to prerequisite. Prerequisite is normality, so you have to check for normality here. Normality of the entire weight on the entire sample. So let's do, what do we start? We start from the test, Shakir week, it's the easiest one. Okay. We check for normality. H0 is weight is normally distributed on population. H0 is rejected. Weight is not normally distributed, which implies that we cannot do student t-test. Okay, we could stop here. I will do anyway all the others as it is required. So, summaries, numerical summaries, statistics. I removed the irrelevant ones. I really hate when you put irrelevant information because it means that you are not concentrating on what is important. Skewness and kurtosis. So skewness is different, very different from 0. Kurtosis is it 3 or was it 0? Because according to some scientists, kurtosis must be 3, according to others 0. Let's see what I told you in the course. So skewness is positive, so there is a tail on the right, which is not present on the left. Okay. Excess kurtosis is very different from 0, meaning that it is too pointy. Meaning that we have a right tail not present on the left. And this can be seen also from the histogram, which we will display right now with the normal curve above. So we have already the histogram, but let's redo it. Histogram of weight. Okay. And since I don't remember how to put a weight, a normal curve above, find out the average and standard deviation. We have them already. Build an histogram, close it, add probe equal to, and rebuild it. So it's funny to close it. So, comma, probe equal to, well, let's change the color also. Red. And rebuild it. Fine. Then we have to add this magic instruction with the mean. The mean is here above. 73.38 and the standard deviation 15.28. So 73.38, 15.28. Okay, let's see this histogram. Fine. Well, it's not really too pointy. I don't agree with kurtosis. Copy it as bitmap. There's only the left tail missing here. Okay. Left tail is evidently missing, while it does not seem really too pointy. I make also my personal comments in disagreement with the other. In any case, it's not normal because there is this part missing. The extra thin people are missing. Let's do the last one. It's the QQ plot. Where is the QQ plot? Here. Portions. I've forgotten where it is, and when you forget where it is, you just look. It's in graphs. Quantile comparison plot. So for weight. Copy as bitmap. Well, here, well, data do not depart from central line too much. According to QQ plot, it could be normal. Well, a little they depart. My word, a stack, is it possible? Okay. At least they depart a little. Well, according to the graphical test, it could be normal, but Shapiro-Wilk normal test, it's pretty clear that it's not normal. Okay. Okay, you can draw here a general conclusion. Well, since according to graphical not techniques, not test, it seems normal. I decide to accept student the test result. It's my personal decision. If you decide vice versa when there is disagreement here, well, I will not blame you. And my word has stuck again. Can it? Come on! What is it doing? These are things that will happen to you during the exam, especially when you have not saved. Okay, let's ignore word. Oh, finally, word. Save. Okay, and let's go on. Analyze whether there is a relation between sex and weight. So, first of all, graphically, sex and weight is well, pretty easy. So we just do the box plot by group, by sex, and I analyze weight. Okay. So there is an evident relation here. Male seem to be fatter. Okay, heavy. This is also true in general. Let's do it numerically and with a test. Statistic means what is the test? Summaries, numerical summaries by groups, sex, weight. Okay. Also, skewness. I have skewness and kurtosis. Have to change it. So I have to change it to mean, standard deviation. Well, this if you want. Okay. Okay. Male average is much larger. So just a comment. Now the test, the student test, paired sample, not paired sample, independent sample t-test. groups decided by sex, and response variable its weight. Okay, it's called Welsh, but all the rest of the world call it a student. H0, average of weight on population, is the same for male and female. Irrelevant information goes away. Sig much smaller than 0.5. Therefore, H0 rejected, meaning that averages are different. Okay, can I get a reasonable font? Okay. Let's do also the non-parametric test. Two-sample Wilcoxon test, which is called Mann-Whitney by the rest of the world. Sex and weight. Okay. Again, no, I have not copied correctly. Then I have deleted it. Let's just resubmit the last instruction here. Copy. Okay. Mann-Whitney. Okay, H0 is position of weight on population is the same for male and female. H0 rejected. Position is different. Okay, well, it was also obvious from the box plot. Let's go on. Analyze whether there is a relation between sex and the factorized version of fit rate built above. So let's see whether the male or the female feels better or worse. Okay, these are two, even though fit rate is theoretically an ordered variable, we consider it a nominal variable. It has only 3 levels. So statistics, where is it? It's a contingency table, two-way table. There is no graphical here inside R. So sex and recorded fit rate. Okay, do we need row percentages or column percentages? Honestly, I never remember. Let's try one and see then later whether it makes sense or not. Do we need the chi-square test of independence? Well, if I just ask for the contingency table, so just a distribution of the sample, don't flag it. But since now here I ask to check whether there is a relation, yes, you need it. It's your statistical test. Let's see here whether the percentages make sense. So, well, first of all, we have 68 female high and 74 male, but we don't know whether the 74 depends on the fact that the males are more or even less. So let's see. No, this one doesn't make sense because it's the distribution. High people are 46% female and 62% male. Oh no, no, it's the other one. So male are distributed 62 here, 6 here, and 31 here. So we choose the right percentages. So we can take everything, the first part, and put it here. Okay, let's comment it out. So male subjects are distributed 62% high, 7% I round low, 31% medium, while female subjects are 46%, 4%, 50%. Okay, so it seems that, well, it's not a good idea to choose high, low, medium, but it will be better high, medium, low. And also here, high, medium, So first of all, we observed that very few people tell us that they have a low fit rate, but it seems that male subjects have a higher self-esteem of fit rate. Higher, not high, higher. Okay, well, it is 7%, 4%, it's not such a difference, but 62, 46, it's a difference. Okay, let's see the chi-square t-test. Let's start the chi-square test. Also, Pearson did also the chi-square test, apart from the correlation. Okay, so we didn't call it Pearson, we just call it chi-square test. H0, classification of fit rate does not depend on sex. Obviously, it's this one and not the vice versa. The sex does not depend on the classification of fit rate. Okay, so the two variables are independent. Significance is smaller than 0.05. It was 0.05, so here 0.05. So we reject, meaning that sex does have an influence on classification of fit. Classification means where do you put yourself in which category. But please check here. Okay, there is no note. If there is a note telling you that there are cells with expected frequency less than 5, you have to write it here because the test cannot be done. It's not just a prerequisite, it's even something more. The test really doesn't work, can tell you silly things. Okay, build an appropriate data structure and insert data of your choice only for the first 5 cases for these questions. Which of these UniBZ facilities do you like more? More than one answer is possible. Or a tricky question, because there are 3 things you can check, but you can check multiple items. When you can check multiple items, it's not a question, but in practice are 3 questions. Do you like the cafe? Yes, no. Do you like the library? Yes, no. Do you like the restaurant? Yes, no. So the structure, I want a structure with 3 variables. So let's do it. Well, I have just tried before to do that with edit dataset. Don't do it with edit dataset. It will not be able to save you things. I don't know why, it's a bug. So never do it with edit dataset. Okay, I will also remove it. It is an official information. Don't do it with edit dataset. Sleep questionnaire $cafe. Okay, you have to do it, let's say, manually. You just add the values. You can add the values in this way. 1 answers no. Op. Person 2 and person 3 like it, so they answer yes. Okay. Now use copy and paste to build up the other ones. So it's not cafe, but it's library. Leave the same, it doesn't cost you anything. Submit, submit. This is the restaurant. And this, I think that no, it's mandatory. Submit, submit, submit. Your data set. Let's see. Okay. I see that it's by default no. Okay. Import file houses.txt into dataset houses using first column for names. Well, before doing it, just to be sure, I will save everything here. Save the script, can you see? Save the output. Okay, and save the workspace. Done. Okay. And also save this file here. Okay. Well, if you want to have give me an idea that you have done it, you can just paste it, but I will look it from here. Okay, so data, import data from text file, name houses, variable naming files, who knows? Let's take a look at it. Yes. Okay, miss data, no missing data, local file system, field separator, tab, decimal point, period. Okay, everything seems okay. Houses. Let's see. Okay, seems okay. Perfect. So we save everything, save output, save workspace, save script, exit R. No, I don't need to save everything again. Close this one, close Word. I will give you 5 extra minutes for this kind of operations. And in particular for this last operation in which you have to copy everything to your network directory. Op, op. When it asks you whether you want to overwrite, you obviously first check that you are copying from the right place to the right place, and then you say replace. Okay, when it will finish next year, exam is over.